Okay, welcome back. We're picking up on the Algebra 2 Semester 2 Final Exam Review and starting with model for problem 29. We're supposed to simplify this expression, and in order to make it in simplest radical form, you need perfect squares up front. So the factors of 63 include 9 times 7, and you can use on your calculator 63 divided by x and the table of values to show that. And then the index on the outside here is a little 2. It's invisible. Square roots don't normally show the 2 there. But since the 12 and the 14 are divisible by 2, we can go ahead and put them up front here. In a minute, those will be divided by 2. So the square root of 9 is 3. The square root of x to the 12th, you say 12 divided by the little 2 that's implied out in front, and I'll give a 6th power, and you get y to the 7th power when you take 14 divided by 2, and there's nothing you can do about that square root of 7. Now we are supposed to use absolute value bars when needed here, and when you have an even index, you look for an odd exponent, and that part is a part that needs to be guaranteed to be positive in order for this to be correct. So you put bars around that portion of it. Okay, problem 30. We have these magic words, assume you're only dealing with positive numbers, which basically tells you don't have to worry about those absolute value bars. Now the 60, if you use your calculator, you go 60 divided by x on the y equals line, and go to your table of values, you'll find out that one of the possibilities here is 4 times 15. So there's your perfect square, 4. And then you try and find numbers that divide by 2. 11 doesn't fit that category. You have to drop that down to 10 for it to work, with the extra x just taking up a position in the junk pile. Now that 8th power will definitely divide by 2, so we're going to put all of that up front. Y to the 8th. And now you take the square root of 4. Sorry about that. The square root of x to the 10th would just be x to the 5th. You just divide the exponent by 2. And then you got y to the 4th. We don't have to worry about absolute value bars. So this problem's done. Okay, I'll do 2 more before I jump to another video here. The like radicals in this one are the root 2 and root 2, so that's the part that you can actually combine. And if you take minus 5 root 2 plus 9 root 2, you get positive 4 root 2. Basically, you just take these coefficients that are in front and you add them and keep that root 2, the part that makes them like terms. Now, you can't go any farther on this. We got a root 6 and a root 2. At first glance, number 32 looks like we're in real trouble here because these have different radicands. You got a 12, a 27, and a 20. And you might not be able to do anything here, but we're going to sure find out once you break these apart. Okay, 12 would be 4 and 3. You got your perfect square up front. 27 would be 9 and 3. You got your perfect square up front. And 20 is 4 and 5. You got your perfect square. So 4 is your perfect square. And there's another 4 and a 9 here. So now let's simplify this. You get 8 root 3 plus 18 root 3. Those can combine. Minus 6 root 5. That's a different radical. We'll have to just leave that one where it's at. So 8 root 3 and 18 root 3 is a total of 26 root 3. So you get 26 radical 3 minus 6 radical 5. All right, number 33 here. Let's see, cube root. We want a perfect cube in the front and anything else in the back. So 8 times 3 would get a perfect cube in. That's 24. The x to the 12th, 12 divides by 3, so I'm going to put it all up front here. 13 does not divide by 3. So you bump it down to 12 and put an extra y in the back. There's your 13. 20 doesn't divide by 3. Neither does 19, but if you drop all the way down to 18, hang on, this is supposed to be z. 18, that'll work, and you need your extra 2 z's in the back there. Okay, cube root of 8. Cube root of x to the 12th. You take 12 divided by 3. Cube root of y to the 12th. 12 divided by 3. Once again, you get a fourth power. Now, 18 divided by 3 is actually 6. And then you've got your leftovers here. Okay, so that one's finished. Kind of a complicated answer. Okay, the last one I'm going to do on this video is number 34, and then we'll switch to another installment. Square root of 21 times square root of 15. Hang tight here. I should have multiplied those. 21 times 15. That's 315. Okay, then you go to your y1 line on your calculator and you type 315 divided by x and go to your table of values. And you're looking on the right-hand side going down until you find a perfect square that goes into 315. And you keep scrolling down. And I'm doing it on my calculator here, and it's 9 times 35. So your final answer is 3 root 35. Okay, so that takes us all the way to problem 34, and I'll pick up on the other side starting with problem 35.